In this video, we're going to do some problems with the greatest common denominators and the Euclidean algorithm. So the first question, we're going to use the Euclidean algorithm to find the GCD of 231 and 1820. Well, first of all, we start by taking A and B. So we're going to find the GCD of 231 and 1820. The largest number, so we have B, is going to equal to 231 times some number plus a remainder. So we need to figure these out. So I see here that 231 times 7 is going to be roughly 1400 plus 210. So this probably will get us close without going over. So I'm going to start by guessing 7 here, because I don't have a calculator on me, so I got to do this in my head. So 7 times 231 is going to be 1400 plus 210 plus 7, which is going to equal 1617. So this total here would be 1617, and then we have to add our remainder. So that is going to be 203 remaining. So remember, for each step, A is going to be equal to BQ plus R. And then in the next step, our B becomes the new large number, so 231, and this is going to be equal to RQ2 plus another remainder. And we're going to keep going until we get no remainder. So 231 is going to equal to 203, this is easy, times 1. And when we subtract, we're going to get a 28 remaining. So now we're going to have 203 is equal to 28 times something plus a remainder. Well, 28 times 7, we're going to get 140 plus 56, which is 196. So this might be a good number to multiply by. So this is equal to 196. And then a remainder is going to be 7. So now we're going to get 28 is equal to 7 times 4 plus 0. So now we are at the end of the algorithm here because we have a remainder of 0. And we see that our GCD is going to be this number here, which is 7. So the GCD of 231 and 1820 is going to equal 7. So that's using the Euclidean algorithm. I highly suggest when you do these, you have a calculator, but of course, if you're in an exam situation, you probably won't have access to one. So make sure you're fairly decent at doing arithmetic by hand. Okay, so second question. This one's trickier. So we're going to let the GCD of A and B be equal to 1, and we're going to show that if A divides B times C, then A divides C. So last time we did a question similar to this, but it didn't have this GCD bit. So this GCD bit is going to change our result and make this true. So first, how do we rewrite this? Well, if the GCD of A and B is equal to 1, this means that we can write 1 as a linear combination of A and B. So this could be that we can have A times some number S plus B times some number T. So using A and B, we can rewrite 1 using a linear combination of them both. So we have 1 is equal to AS plus BT. Now, we're going to assume that A is equal to B times C. So we're not going to write anything explicit, but we're going to have to do a trick to prove this result. So we have A divides C in the end. That's what we want to prove. So it'd be nice if we could turn this 1 is equal to AS plus BT into C is equal to something. And we can. So we're going to multiply this whole thing by C. So we're going to get C is equal to C times AS plus C times BT. Okay. So now, in this first part here, we have that A divides A. So that's good. In the second part, we're going to use our assumption that A divides BC because we have a BC here. We know that A is going to divide the second term. And because A divides both terms, we know that A is going to divide C. Because if A divides the first term and A divides the second term, then A will divide the addition of both terms. So you may remember the theorem that if A divides A, and A divides B, or sorry, this should be a C here, then A is going to divide B plus C. So that's the first theorem we need to use for this. The second theorem is that if A divides D, then A is going to divide dk for some k. So using these two theorems, we can prove that because A divides the first term and A divides the second term, then A is going to divide the whole term. So if the GCD is equal to 1, if A divides BC, then A is going to divide C. Okay, so those were the two questions on divisibility with the GCDs and Euclidean algorithm. So if you have any questions, please leave them in the comments below, and I'll answer them the best that I can.